Okay, was anyone able to complete the Hello World 1 this weekend? Anyone? Okay, so we got some people that are close. A couple people finished. Yeah, so as a reminder, so Hello World 1, 2, and 3, you must finish them this week. Next week, in section, is when you will have your checkoffs, either section or office hours. So you will need to make sure that you do that sometime next week. But yeah, please try to finish this week. What happened last time, well, let's keep our voices down. What happened last course offering is some people tried saving it till the last minute and then realized like, oh shoot, this is a project that requires like 30 plus, 40 plus hours of work. And they suddenly realized they had to do 40 hours of work in like 24 hours. So please start working on it as soon as possible. If you have any issues with Hello World 1, 2, or 3, please let us know as soon as possible. I didn't see any people posting on Piazza over the weekend, so maybe that's just because it was seamless and easy. But yeah, please work as soon as possible on Hello World 1, 2, and 3. I want to quickly show you what Hello World 2 looks like, what the C file looks like. Okay, so take this in really quick. Maybe turn to the person next to you, like look at this together, and explain what this effectively does. Okay, let's go and chat. What's going on here? Sorry. Okay, there we go. Okay, so it's a hello world still. So we have this stdout stir. So this will be printed out to stdout. We can see like it's setting this this address. So remember, if you remember stdout, this is a hard-coded address. It is set to like OX7110 or something. That is just the address of where stdout, like the memory mapped stdout is. And what we are doing is we are iterating through this string, and every iteration of loop, we are printing out each next value into stdout. So there's multiple things you'll need to get working here. One of the things you'll need to get working is loop. So you will need to first like run setup, and then accept, be able to return back to the operating system. And then after you have run the operating system routine to handle return from setup, then you will need to jump into loop. And then you will need to make sure to continually as you can see. But kind of most important thing, though, is that there is, I believe there is something where you have to fetch from stdin. Am I saying this? stdin. Yeah, so here's, so for get name, has anyone gotten Hello World 3 working by any chance? Okay, yeah, so I guess I could run it. I'll run it a bit. But yeah, you'll have to get stdin working. But kind of the most important thing, though, is this part right here. Okay, so when you write code, there are actually multiple different places that your code will go into on your computer. What happens when you run a program, when you do like /echo or /any program, your code will be loaded into one specific part of your RAM, but then your stack will be in a different part of your RAM, and your heap will be in a different part of your RAM. And it's very similar in our case, so we have all these like const members right here. All these const members, these are really easy to deal with. These are all just going to stay in your ROM, so they don't need to be like loaded into any sort of volatile or any sort of manipulable data. But this array right here, so what this is this is creating an array that is the size, name entry max size, which is 20 integers. So it's initializing it all to 20 zeros. Okay, and since we are specifying the data that is inside of this, we actually will need to copy this array now into a manipulable, like a writable part of RAM. We can't just store this in ROM. Okay, right, because if we can easily just have like this int name, we can have this be in ROM because we're not going to modify it. Read-only memory does not need to be modified. But this part right here, we cannot leave this in ROM. This is a bunch of zeros that we need to make sure that whenever we read from this, it is zeros, but also when we write to it, that data is properly written. Okay, can anyone guess what happens when we have like initialized, like global and like pre-initialized values like this? Like where would this, how is this probably handled? No. Yeah. Not quite the stack. Yeah, so absolutely. So usually if you initialize a variable like this, then when you push it onto the stack, that data is being initialized. But in this case, for global variables like this, that is not what happens. We aren't like pushing anything to the stack on initialization. Yeah. Well, it turns out that there's actually a, let me see, can I? That's okay. There's actually a whole section of the address space that talks about this. And maybe you have all kind of looked through this already, and maybe we're a little bit confused. But so let me scroll over to it. Okay, so here's the slug address space. So of course it specifies the starting of the slug file, the magic number, the address to setup, address to loop. We've already talked about that. But what we haven't talked about is this load data address and program data address. Okay. Do we have any thoughts now of what this could potentially be used for? Okay. Any guesses? Yeah? Yeah? Okay. Why are there these extra addresses here? What do they specify? And how is that related to this like pre-initialized data up here? Yeah? Uh-huh.
Basically, you're either reading the program data, but you're like getting input during the wrong runtime, or you're also loading it if you want.
I think you're on the right track. So what? Oh, yes. Okay, sorry.
So the load address is where it's going to load it into. The program address is where it is in the file of the slug file itself, and then the data size is how big it is.
Absolutely. Yeah. So what you'll need to do, there's actually, if we search in this file, I'm going to quickly search. If I search for data, then it talks about this data section. It says right here. So during the reset sequence, we will actually need to copy the data section into our RAM. The idea with that is the data section exists on the ROM. Like we have the list of pre-initialized zeros, so those exist in the ROM. And then what we need to do is we need to copy all of that data into RAM. And now anytime that we read that data and anytime we write that data, instead of accessing the ROM addresses, we're now going to be accessing the RAM addresses, which we are in fact allowed to read and write. Okay. If this is making sense, maybe turn to the person next to you and explain to them once again what I'm saying. So maybe explain to them what is the purpose of the data section and what does it mean to copy the data section to RAM? Yeah. Okay, cool. So hopefully this all makes sense. I'm going to quickly create another file. So let's call it like hello world 4 or something .c. Okay. If I now make, like void setup. And now let's have something where I maybe call it like const int I equals 6. Okay. Question to you. What is the size of our data section? How much data will we need to copy into RAM for this program? Can everyone hold up on fingers? So if an integer, remember, is 4 bytes. So hold up if you think it's 4 bytes. Hold up if you think it's 0. Hold up if you think it's like 10. Okay, in fingers, maybe kind of just on your chest, how many bytes do you think are copied to RAM? Okay, so this is const. So can this be manipulable? We can't modify this. So therefore, it actually exists in ROM entirely. So we're not going to copy anything. So therefore, the size of the data section is 0. Okay. What if I change this to this? Okay, how many bytes now is it? Okay, now it's 4. Yeah. Okay, what if, I don't know. What if it was that? I guess it's kind of hard to, what if it's that? No, it's still not good. That's fine. I'll do uint8t. Okay. Const. There we go. Okay, how many is that? How many bytes is this? Being copied from the data section to RAM at initialization. So how many bytes is a uint8t in general? A uint8t is size 1, yes. And if we have a const uint8t, that means we don't have to copy it to RAM because we don't need to ever modify it. In this case, the data section would be size 2. Yeah, okay. So this is just, I'll continue kind of throughout the quarter, I'll continue kind of pull up little tidbits on things that are kind of confusing that I've seen on the documentation for the Banana Slug project. Yeah, so this copy data section, this is just one of the steps that you will need to worry about in the reset sequence. So yeah, kind of just go through the reset sequence, go through the game loop sequence. This is going to be kind of the most important thing for working on Hello World 2. Okay, because I'm assuming most of you are mostly done with Hello World 1 at this point. Yes, question?
So why exactly do you say, if you have const, you don't have to, how is the data stored?
Yeah, so if something is marked as const, then that means that it just exists in the ROM and won't be modifiable. So we don't need to copy it into RAM. Yeah. So actually, maybe another thing is, can we guess, maybe just roughly, what will the address of this value be? Like if we were to just guess, like where in our address space would this probably be? If I call this like I0, I1, I2. Okay, I0. Where roughly might this be? So it's not in the stack. Because the stack members, if you remember, that's when you enter a scope. So if we created like an int like a here or something, this would be created on the stack. But these are not stack variables. These are global variables. Okay? Yeah. Yeah, exactly. So this will be at the program data address, or sorry, at the program data address, which is, I don't know, we can guess maybe it's around like address like OX like 0010 or something. But then this variable right here, this I1, where could this probably be if we were to just guess? Plus or minus like 1,000. Yeah. Go for it.
I would say it would be in the ROM, so like 8,000 something.
Yeah, sure. So this will be in the ROM. So anytime we read from this value, or even try writing to it, which should fail, then it'll be, I don't know, maybe somewhere around there. And then, of course, yeah, for this last one, it is also being stored in the data section. So this might have an address of like, yeah, I don't know, something like that. Okay, cool. So hopefully this is insightful. Good stuff. Okay, that's all I was going to talk about on the final project today. We also will have a quiz on the final project at 4:50, so look forward to that, in about half an hour. Before that, we are going to start talking about inheritance. Just wondering, on a scale of maybe like 1 to 5, 1 meaning like you have never heard of inheritance and maybe you've never heard of inheritance, maybe 3 being like you have used it before but you don't regularly use it, to 5 being like you use it all the time. Can you just show me like on a show of hands, like where are you kind of at? Okay, that's super interesting. Completely different from last time I taught this class. Almost everyone said like they had never even heard of inheritance. That's great. I'm going to kind of blow through kind of a little intro to inheritance. Honestly, inheritance is not too common nowadays. It's often frowned upon. Object-oriented programming is falling out of fashion, and we're going to talk about why on Wednesday. So today I was going to talk about just an intro to inheritance. Lecture on Wednesday will be all the reasons why inheritance fails and the reasons in which you should never use inheritance. And then lecture on Friday will be all of the ways that inheritance is actually really useful and you should use inheritance. So that is the kind of the structure for this week. And then next Friday, there will be a homework assignment on inheritance. There's no homework assignment this week because I want you all to work as hard as you can on getting the final project done, Hello Worlds 1, 2, and 3. So no homework due this week. There is, an inheritance assignment due next Friday. So, okay, cool. Yes, so good stuff. So I have this prepared example right here. Okay, so we have a point class, which just has a double x and y, and we have a polygon class, which is effectively just a vector of points. And then here I have a main file, and we can see, so I'm creating a polygon. In this polygon, it looks like it has 3 points. So this is a triangle, and then we can print out the area using this area method, which is inside of the polygon class. Cool, and it does something. I believe this algorithm is called the shoelace algorithm, where it will effectively kind of like jump across and make triangles as it like kind of searches through this polygon. Okay, so let's quickly run this. And so I have this CMake file right here, so you can see it grabs source main.cpp and source polygon cpp. How do I run CMake files again? What's the someone shout it out? What's the first thing? Yeah. Yeah, okay, build directory first. Yep, so let's make dir build, cd into build, and then now what do we type? CMake dot. Yeah, cool. So this will now grab the CMake lists file that is one directory up. It'll grab the CMake lists file. Okay, CMake dot. And this is generating for us what? In make files, yeah. So this generates us make files, so now we can run the make files with make. If we want to do it multi-threaded, to make it a little bit faster, might be useful for your final project. What you can do is just type in -j and then specify the number of cores you want. In this case, I could say 8 cores. Okay, sure. So cool. So you can see it's running pretty quick. Ran all that. Good. So now I have shapes built, so I can run shapes. There we go. So it looks like it has an area of 10,000, and I also created a polygon.svg. So I can open this up if I want, and there we go. So there's the triangle that I just created. Good. And so maybe polygon class, maybe this is all you need. But maybe this is quite filled out. Maybe I really like this area calculator. I really like this create SVG. I really like the structure of this class. But maybe I want a generator for a rectangle class. Okay, so maybe what I could do is I could kind of just take this polygon class and I could just name it rectangle. Okay, and instead of polygon, maybe I could call it rectangle. Okay, and then this rectangle could also have just an array of points as well, and could also just have this area and perimeter, and it could just be an exact copy of the polygon class. But this is not considered very good, usually, because this is not considered dry code. Anyone heard of dry code before? Dry? Yeah, okay. So dry code, this is kind of one of the most important ideas in all of computer science. So dry code means don't repeat yourself. And that is kind of the whole purpose of creating like functions and branching, like for loops. The whole purpose is that you kind of only want to write an implementation one time, and then you just call that implementation as a function. So in this case, we've already implemented this area, perimeter, and create SVG. It'd be nice if we could call the polygon class instead. So okay, in your opinion now, what is maybe a better way of creating a rectangle class? So that we can reuse the code. Yeah? Absolutely. We can have rectangle inherit from polygon. So yes, in C-like languages and object-oriented languages, you have something called inheritance, and I'll show you the syntax for that. So it's where you add this colon here. In Java, I think you write like extends or something. In Python, it's something different. But yeah, almost all object-oriented languages have some sort of inheritance thing. In this case, yeah, so we do the colon, and I'm going to say public to just give us full access to everything. And then I can type in polygon. And what this does is it means that now we have access to all of the member variables and member functions of our polygon class. So now we can just get rid of all of this, and now rectangle will act exactly the same as polygon. And let me actually also go and include polygon. Okay, good. But now we probably want a constructor for this, because like we don't want to just use the polygon constructor. So okay, so in order to create a constructor, in this case, so rectangle, what sorts of things would a rectangle class probably need as a constructor input? Yeah. Sure, height, yeah, I like that. What else? What's the other one? Width, okay, and then what's the last kind of thing it may need? Maybe like a top right coordinate or like top left coordinate. Yeah, okay, sure. So let's go and do that. So let's make a point that is like top left. If we're adding in a point, then we should definitely pass it by const reference, because point, that's two whole doubles. If you remember, it has an x and a y coordinate, so we probably don't want to pass that by value because it would copy a lot of data. So okay, so cool. So that is point. Let's call this, I don't know, top left. Sure. And then we can have double height, double width. And I will do, sure. Okay. And so now here are the inputs of my constructor. How could I now fill this out to now implement this correctly? So in theory, you know, one thing that I could do is I could just fill out this points array. Like I could come in here and I could say like, oh, you know, if points like dot push back or something, and I could add like this top left thing, and then I could add all four corners. I could do that. But for those who have used inheritance before, has anyone heard of a super class or a super constructor? Yeah, okay. Could anyone explain to me what a super constructor is? Maybe someone else? Oh, yeah. Brown shirt. Yeah. Exactly, yeah. So a super constructor is when the child class calls the base class. constructor. So in this case, so yeah, let's do that. And the way you do that is with an initializer list. So we can leave this implementation empty, but what we can do is call this polygon constructor, and I'll put this on a new line. Sure, it's fine. Okay, and then inside this, we can now just call this constructor. So this constructor, you can see it takes in a points vector. So now we can probably say, so top left here. Okay, and I can say, there we go, that's good. Top left, and then, okay, and then after that, we can say, like, maybe like top left dot x, top left dot y, and for each of these. But then we need to factor in the height and the width, so maybe x, maybe it's like plus width, and then this is maybe like this. Oops. Okay, so now we have all 4 of our corners set. We have the top left, which is correct, and then we add the width, and then keep the y value, and then we add the width and the height, and then now we go back to the same x value, but we keep the height. Okay, does this look right? I think we're good. Kind of just going for it. We're good? Okay, good. So now we have this constructor. So now let's try like testing it out, I guess. That'd probably be good. So in main, so we can take this polygon, kind of snip it right here, and maybe swap this out for our rectangle. And I'll swap this out for R. And our new constructor does not take in a list of a list of points anymore. What does it now take in? Our rectangle constructor? Okay, yeah, so maybe just our top left point for now, we can just keep it at 0, 0. Okay, and maybe our height and width can be like 50 and 40 or something like that. Okay, let's also include rectangle. That would help. Rectangle. Okay, and unfortunate. What's going on? Maybe it's still fine. Let me know if you see anything weird. Oh, and we can just rerun this. No, we can't. Yes, because we need to build. There we go. Okay, it looks like it's actually fine. Good. Oh, you know, I edited the wrong file. That's why. I apologize. Okay. Sorry. Okay. Sorry. Technical difficulties. I edited my starter file. Okay. So now main, we can copy this over. Good. And then this is also there. Okay. This looks more correct. Okay. Yes. And okay. Does anyone see what my error is? So if I open my rectangle class, it says that it is private. Does anyone see the issue? Yeah. Yeah, exactly. So here I have this class, but I didn't actually specify that this should be public. Okay, so hopefully that now fixes it. Yeah, fantastic. Okay, cool. So now we've done that, and great. So now we can see we have our polygon still. That is correct. Let me rename the this to be rectangle. Okay, there we go. And so now rectangle.svg was created. We can open this up, and nice. We have a rectangle. Good. And then this is the area of this rectangle. Okay. So that is kind of roughly how inheritance works. Now, can everyone chat with the person next to you? What would it look like now if we wanted to make a square class? All right, any ideas? Anyone in the back? Anyone in the front? Anyone? How do we do a square class? It's probably pretty similar to the rectangle class, right? How would it be different? Yes?
You could make a class that inherits from rectangle,
Oh, okay.
and then the constructor would just, instead of height and width, just have like a side length.
Oh, sure. So yeah, maybe instead of rectangle, instead it is a square class that inherits from rectangle. Rectangle, okay? And so rectangle, it's going to be pretty similar to, like square class is going to be pretty similar to rectangle, except now instead of passing in the width, maybe we just pass in the height or something. And then now we can, instead of passing in like all of these points, now we can just pass in probably height like twice here. So we say height because the height and the width must be the same for a square. So, okay, cool. I think I'm spelling rectangle slightly wrong. Rectangle. Wait, never mind, I have to include it, okay. Okay, and I think I can leave that out. Cool, there we go. So yeah, this is great. Like I was able to create a square class. Now I can make a square constructor. I can go into my my main.cpp, and I can create now a square really easily. I can just give it like a side length of maybe like 30, and I can call this square. Square. I also have to include square. And S and square. Ah. Thanks. Nope. Okay, cool. Okay, good. So now when I remake this and run this, then yeah, look how easy the interface is. Now I can create squares. This is great. Wonderful. Okay, so yeah, that's kind of inheritance. Yeah.
For the square, can you still use the polygon constructor?
Oh, great question. So the question was, so from square, could we call the polygon constructor? Well, that would, in a way, kind of defeat the purpose of using, like, inheriting from rectangle. And in fact, I don't think you can do that. I think you need to call the superconstructor from only the things that you are inheriting from. I've not seen anyone who has like inherited from like a class that's like further down. Maybe it is possible though. Yeah, question.
I was going to ask about like the initializer sort of list.
Yeah.
There is, it seems like I was thinking that was like not work, but it seems like it's working.
Mm-hmm.
Having the curly braces and everything. I think the rectangle doesn't take a list. It takes just 3 parameters.
That is really weird. I don't know why that's working. That's really odd. Oh, I do. What was happening is, that's funny. So when you actually put curly brackets like this, yeah, that was a bug that should not have happened. But what was happening is, so I had my curly brackets like this. So in place, like right here, this is actually considered a rectangle object. And so what was happening is I was actually calling first the rectangle constructor, and then I was calling a copy constructor on that because I was passing in rectangle into rectangle. Yeah, that's funny. Good catch. Yeah, thank you. Cool. Okay. So, oh yeah, another question?
So if you didn't comment out with the polygon.h, wouldn't the pragma one steal with the inherit?
Yes, it would. Yeah, it'd be fine. Okay. Cool. So this is great. So now we have these. Another kind of important kind of thing about inheritance is the idea of overriding functions. Because if you remember, so we have, so the square function, this square class does have this dot area method. So we are able to get the area. And remember, it uses this kind of complicated shoelace algorithm where it like laces up triangles and adds up all the sum of all the triangles. It's kind of a slow and kind of complicated process. And we know that calculating the area of squares and rectangles is really easy. You just multiply width and length. So maybe what we could do instead is actually override this area function. So inside of a rectangle, what we can do is we can just grab the same kind of API that Polygon had. So we can take this area right there. So it looks like, yeah, it returns a double, doesn't take in any members, and is const. Okay. So now we need to return the area. And it looks like I don't actually store the width and height anywhere. But maybe what I can at least just do is just take the difference between 2 points. So maybe I can say like double, like, width is equal to absolute value in case things are weird, like top left dot x minus, top left, sorry. No, I can't access top left either. So let's do points. Yeah, points, maybe dot at 0 dot x. Yeah, cool. And then maybe we can grab like the opposite corner, which will be at 2 dot x, okay? And then for height, it will be pretty much the same thing, except now it will be y. Okay? And then we can just do return what? What do we return? Yeah, width times height. Cool, great. Okay, great. So let's see what happens. And maybe just to double check that we are that we are in fact running the correct function, let me just go and add a little cout right here. I think there's some sort of way, is it pretty, well, kind of, function, is that right? Ooh, now I can't remember. Wait, let me quickly double check. There's this nice C++ method that will expand out. Yeah, let's do it. Okay. It will expand out into the name of the function that is like calling this macro. So let's do this. So and then end line. Okay. And so let's put this in rectangle, but then also in polygon. There we go. So now I can make this. And, oh, I just need to IO stream it. Rectangle, IO stream. Excellent. Shapes. Okay, so let's see if this makes sense. Okay, so now we can see that the area function was called first from the polygon, which I believe that makes sense, right? Because we're calling it from polygon. Oops. Okay. And then after that, we can see that the rectangle area was called instead, then the rectangle area was called instead. And that's fine, right? Because with square, even though square did not override area itself, square did not override area, we still were able to grab it from the most highest level overridden function, which was from rectangle. So, yeah, pretty cool. Okay, ponder this for a second while I grab my charger. And now also ponder the idea of polymorphism. Okay, maybe explain to the person next to you what polymorphism is, or ask the person next to you if they know what polymorphism is. Okay. Does anyone have a good definition of what polymorphism is? Okay. It is so inheritance is a great way to create polymorphism in your code. So polymorphism is this idea that you maintain functionality of an object even while it is being treated by some other type. Okay, so I'll kind of walk through what that would look like. So because all of these classes, so this polygon class, rectangle class, square class, technically they're all considered polygon classes still. Like their base class is still a polygon. What we can do is, if we want, we can make a polygon vector. std vector polygon, and you know what, let's make it a polygon reference or a polygon star, and we'll call it p. And let's pass in each one of these. And notice this is a polygon star, although we are still going to be able to pass in both like the rectangle and the square into this. So watch what happens. So I'll do like, I'll grab the reference of P and also the reference of R and also the reference of S. And now if I want to iterate through this and get the memory of, or sorry, get the area of all of them, I would probably do a for loop. How do I do a range-based for loop again? What's the syntax for this? So you could do like int I equals 0 and go through the size of them. That would work. A more kind of modern, kind of elegant C++ way. I would create it as I would do const auto reference. So what this will do is it will make it so that I can't modify any of the things as I'm reading through them. It also will it'll infer what each of the types are, which are going to be a polygon star, and then reference, meaning that it is passing it by a pointer. So maybe it's not as necessary because it's a pointer to a pointer, but anyways, and then I will say, I can't do P again. Let's do this polygons. Okay, P, good. So now I have all these P's, and then I do this single colon here, and then polygons. So what this will do is it will create a for loop that iterates through every element in my polygons array. Oh, you know, and I can't do P, so I'll call it like Pi. Yeah, cool. And so now I can do Pi dot area. Okay. So what do we think is going to happen? So do we think that it's going to print out like kind of the same thing where it's like polygon area, rectangle area, or it'll be like polygon area, rectangle area. Okay, let's see what happens. I'm actually going to comment out all of this stuff just to kind of keep it cleaner. Okay, so let's see what happens. You poke the person next to you and be like, I think it's going to do this. Okay, you ready? All right. Uh-oh. Okay, what's the issue here? We were expecting it to say polygon, rectangle. Because like the rectangle class, like it implemented a rectangle area function, which is in theory going to be like really fast and it's going to be way better. And so we're kind of upset, right? Because it's like, we spent all this time implementing this really fast and elegant area getting algorithm, but it's still calling our base class. The reason for that is even though like we are treating these, or because we're treating these as polygons, it is automatically going over to the polygon class, and it isn't like looking up the child tree. Like it isn't finding anything above. It isn't finding exactly like what each one of these pointers actually are. The way to fix that is to in Polygon, there we go. Yes, in Polygon, all we have to do is just add virtual here. Okay, and what a virtual function will do is now it will do like an O of n operation where it will check if the child above has an implementation, and it'll check the child above if it has an implementation. So now let's go and run it and see what happens. Hopefully this will fix it. Yeah, there we go. So now we can see that this works as expected because now because we've labeled this as virtual, and this rectangle is like secretly it's a rectangle class. That means that like at runtime, we determine that this is a rectangle class, and then we go up the tree. And so first, we check like, okay, like is this considered virtual? It's like, yes, it is considered virtual. So we'll use the area function if nothing else is implemented, this area method. But like this will only be a fallback. Most likely we'll override it. Okay. Then we go up one level, and we see, okay, so we actually have implemented an override. So this is now going to be what is overridden. Great. And then we can go one level above that. We see, okay, do we have an area function here? No, we don't. So therefore, we are going to just fall back on this rectangle function. So that is the idea with polymorphism. It's the idea that you cast an object to another type, but it maintains the functionality of the true type that it actually is. Yeah, cool. Any questions on this? There's one more thing that I wanted to quickly show before we move on to the quiz. We good? Feeling good? Okay. Hopefully this is kind of a review for a lot of people. I will say you're probably not going to need inheritance in your final project. In fact, I would maybe even recommend just not even using inheritance in your final project. There's not really a good place for it. But you will need to use it in your homework 5, which I will release hopefully tomorrow. Okay, cool. So there's one final thing that I wanted to show you. So what if now, so this polygon class is great. Maybe we also have some method here that is maybe like void, like get perimeter or something. Let's also make it virtual. Virtual void perimeter. It's close enough. Okay. So what we can do if we wanted, maybe this perimeter class is too complicated to implement in Polygon. Maybe like we really want to delegate this out to the children classes. Like maybe we don't want to implement it ourselves. We instead want anyone who inherits from us to implement this class. And in order to force that onto the child, we can add this equals 0 here. And what this equals 0 will do is this means that it is a pure virtual function. So what a pure virtual function is it means that this polygon class cannot exist on its own. And instead, anything that inherits from Polygon must override this perimeter class. So now if we try compiling, then what we see is we get an error, and I believe it should say something about, let me see. Yeah, it says cannot declare variable s to be of abstract type square. Abstract type, okay? Have we heard of abstract types before? So the idea of abstract types, an abstract type is a type that has a pure virtual function. So pure virtual function, I'll say classes with virtual functions are abstract. Okay, it's kind of just semantics things. We'll talk more about pure virtual functions on Friday, because actually pure virtual functions, from what I've seen, seem to be the most popular use case of inheritance. You actually almost never want to just have a regular virtual function. And the reason for that is because it's so slow, because you have to walk up the tree of inheritance in order to find the correct function to run. A pure virtual function is like the correct way of inheritance in kind of the modern day. Any questions on any of this? Okay, great. Okay, cool. Okay, so this is a what application is this called again? Okay, it's a hex editor. Yeah. And each one of these bytes represents a different byte in the file, right? What do these top numbers represent up here? Yeah, you can just kind of shout it out. Anyone? Yeah, so okay, so it's the byte offset, but you can see, so this top number concatenated with this left-hand column, that forms the entire address. So if we want to access address 73, okay, then which column would we be interested here? Probably this 3, okay. And then what row would we be interested in? Okay, 7, yeah. Okay, cool, good, okay. Now, register files and CPUs, okay. So are register files large blocks of memory that stores ROM files? And they're kind of small, right? Do they store CPU instructions? Yeah, they also probably don't store CPU instructions. That would probably be like, the ROM, okay. Is a register file the process of initializing all internal CPU registers? Yeah, it's not like a process. It's a thing. So what is a register file? Yeah. Okay. So it's a small block of memory. Probably just like 32 integers all in a row. That's probably what a register file is. It's a file cabinet almost of just 32 registers. Okay. Cool. Good. So in this case, what is even this? Okay, so reg A. So it looks like it's this segment right here. Does it matter whether it's an R-type or I-type instruction? Okay, no matter what, it looks like it is going to be bits 21 to 25. How many bits wide is this? Yeah, this is 5. It's bits 1, 2, 3, 4, and 5. So 5 bits. Okay. So therefore, the output here, we know that the maximum that this can store will be 5 bits. So we know right off the bat that probably it's not going to be this one, because this requires, I think 8 bits. Okay, so it can't be this. So it's probably one of these. All right. I'll leave that for you to kind of figure out. Okay. Okay, good. And then this last one. So do you remember? So the purpose of the data section is the idea that we store something from the what? From the ROM. So okay. And then you put that in where? Put that in RAM. Okay. And and that's all the data. Is that the initialized data or the uninitialized data? It's the data that was initialized to something. That's why we need to copy it over. If it wasn't initialized to anything, we wouldn't need to copy it over. Okay, well, that's time. I think if you submit a little bit late, I don't think it actually penalizes you. So that should be okay. All right, well, good work, everyone. Please finish Hello World 1, 2, and 3 by the end of this week. Go to section with questions. Work really hard, but great work. Okay, see you on Wednesday.